Second law, net force is equals to rate of change of momentum. Is given by m dot multiplied by vx minus ux. That is the final velocity minus initial velocity. The mass flow is given by the product of density multiplied by area multiplied by velocity, where v is the velocity of the fluid. If the plate is moving with a velocity equals to u, then the approach velocity will be given by v minus u. In that case, we have to use the equation rho into a into v minus u. So this equation you have to use for fixed plate or fixed vane, and this one is for moving vane. In this figure, this plate is fixed and the jet is coming from this side through the area A, and when it impacted, it will leave from this side with a velocity equals to v. This one is fixed. When the jet will approach from this side, it will strike. No component of this one will reverse back. Rather than this, the velocity, the component of the velocity will be tangential to the plate. It will leave from this side as well as will leave from this side. So the return velocity will be equals to 0 in the same x direction. The product of density multiplied by area multiplied by velocity. Plate is stationary, so u is equals to 0. And therefore Fx, that is the force along the x direction, is simply given by m dot into, actually, so we are finding the reaction. So we'll take initial minus final. So that is v minus u. So v1 minus v2. But v2 is 0. So this equals to m dot multiplied by v1. Since the displacement of the plate in the direction of x is 0, so work done is equals to 0. Basically, work done is defined as Fx multiplied by u. But u itself is 0. So work done is also equals to 0. In the second case, the plate is inclined at an angle of velocity will be equals to v, and the final velocity will be equals to also v on both sides. We will solve this problem assuming this case, because this is a simple case. If we assume that this is a normal and we'll consider only this component of velocity, in that case the return velocity will be 0 in this direction. So what we do is that we'll resolve the value of v along the direction of plate. So this one is v. One component will make perpendicular to the plane, that will be normal, and other is perpendicular to this, so that the vector will be same. So this angle will be theta, this will be 90 minus theta, so this component will be v of cos of 90 minus theta. But is cos of 90 minus theta is same as sin theta. So this is v times sin theta. Now similarly, we will show this normal force. If this is a normal force Fn, then what is this angle? Is it 90 minus theta? If it is 90 minus theta, then is this angle will be equals to theta. Correct? If this is theta, then is this component will be, this is sin theta, and what will be this component? Cos theta. So Fx component will be Fn sin theta, whereas Fy component will be Fn cos theta. So mass flow rate will remain same, is m dot is equals to rho multiplied by a multiplied by v. For this normal direction, is it equals to rate of change of momentum? That equal to what? M dot. What is the velocity vector in this direction? Is it same as vn? Correct? And what is the return velocity in the same direction? Is it 0? So what we done? We have calculated Fn. Is it equals to rho multiplied by a multiplied by v, but what is vn? Is it v sin theta? So this value of Fn equals to rho times A times V square sine theta. But what is Fx? Is Fx equal to Fn sine theta? So Fx equal to Fn sine theta. So what is the value of Fx? Fn will replace like this. So is it rho times A times V square sine of what? Sine of square of theta. Similarly, what is the value of Fy? Is same as Fn into cos theta. That will be equals to rho times A times V square. Is it a cos square theta? So we have two components. One is a sine square theta and one is cos square theta. Second component will be cos theta into sine theta. That can be done as 1 by 2 times rho times A times V square. Is it sine of 2 theta? So in this case the blade is moving with the velocity equals to u, which is much lower as compared to velocity of v. Then only the jet will strike on the blade, strike on the vane. To solve this problem or to make it simplify, what we do is a method of relative velocity. We assume that the plate is fixed and the jet is coming with a velocity of v minus u. Because of relative velocity, the mass flow rate is given by m dot equals to rho times a multiplied by approach velocity v minus u. The jet is striking with a velocity of v minus u. In the same direction, return velocity will be equals to 0. So Fx is equals to m dot multiplied by the approach velocity v minus u minus return velocity equals to 0. So Fx will be equals to rho times A times v minus u square of it. Now this time the plate is continuously moving, so work done is possible, and work done is given by Fx multiplied by u. U is the distance traveled by the plate in 1 second, or same you can call it as power also if you take meter per second. In this case the plate is inclined at an angle of theta, but the plate itself is moving with a velocity equal to u. The jet velocity equals to v. So again we apply the relative concept and we assume the plate is fixed. So jet will approach with a velocity of v minus u. So what we do is that we will resolve the first velocity, that is the relative velocity, in two components. This one is v minus u. This one is sin theta and cos theta components. This angle is same as theta. This one is 90 minus theta. So this component will be equals to v minus u. Cos of 90 minus theta, that will be same as sin theta. And we call this component equal to normal component. Similarly, we will consider the force, the normal force here. So this normal force is Fn. It can be resolved into two components. Angle made with the vertical is theta. So this one is Fx equals to Fn sin theta, and this will be Fy equals to Fn cos theta. So your answer is almost same, except every value of v is replaced by v minus u. So mass flow rate will be equals to density multiplied by area multiplied by v minus u. Then we calculate the normal reaction Fn. The normal reaction Fn will be equals to m dot multiplied by this component, that is equal to Fn. The velocity in that direction will be equals to v minus u times of sin theta, and the return velocity will be equals to 0. So this is same as rho times A times v minus u square sin theta. If you are interested in x component, then x component will be fn of sine theta. So this will be equals to rho times a times v minus u square of it and sine square theta. Whereas fy component will be rho times a times v minus u sine theta cos theta, which can be written as 1 by 2 of sine of 2 theta. The work is only possible along the x direction because blade is moving in the x direction. So work done along the x direction will be fx multiplied by u. Work done along the y direction will be equals to 0. In this case we have a curved vane, but the curved vane is a symmetrical one. That's why the angle made equal to what? Theta and theta. So when the velocity will approach as a v1, it will return back with a velocity equals to what? Again v, but at a direction equals to what? Theta. Plate is fixed, so u is equals to 0. Now in this case we will resolve this velocity v. So this velocity v is like this. So it has two components, one will be like this and one is like this. So what is this x component? So x component will be, this is same as theta. So is this component is v cos theta. We are only interested in the x component. Since the plate is fixed, the jet continuously approach with a velocity equal to v. So mass flow rate will be the product of density multiplied by area multiplied by v. But the force along the x direction can be obtained by taking the momentum balance along the x direction, which is equals to m dot. The initial value will be equals to v and the return value will be equals to minus, and that is the vector component, so it is equals to what again? Minus v of cos theta. The rightward value of velocity is considered as positive and leftward is taken as negative. So the total force acting along the x direction is a product of m dot, and we have here v plus v multiplied by cos theta. So this equals to rho times a times v square, is it multiplied by 1 plus cos theta. And work done in this case will be equals to what? 0, because the plate is fixed. Plate is moving with a velocity u in the x direction. Same equation you can apply. Only thing that you have to replace the value of velocity, that will be the relative velocity v minus u whole square into 1 plus cos theta. Now this time is the work is possible. So yes, work is possible, and is it equals to fx multiplied by u. So we have to resolve this velocity first. The inlet velocity will be resolved like this. So this one is same as v. Is this angle is same as theta? Is it same as theta? They are alternate angles. This one is theta, so this one is also equals to theta. So what is the component? This is v times cos theta, and this is v times sin theta. Same is true on the other side also. So if this component is v, then we have two components of this, one along x and one along y. So this will be v, this angle is same as theta, this component is v cos theta, and the other will be v sin theta. Since the plate is fixed, m dot is given by the product of simply rho multiplied by a multiplied by v, because u is equals to what? 0. So if you want to calculate the force along x direction, so you have to consider the momentum balance along the x direction. So this will be m dot, entering value will be v cos theta, minus leaving value will be same as minus v times cos theta. So this will be equals to m dot This one is v cos theta and this is v cos theta is 2 times of v cos theta. So the final equation will be 2 times rho times a v square multiplied by cos theta. So work done along the x direction will be equals to fx multiplied by u, but the plate is stationary, so work will be equal. A jet of water of 50 mm diameter strikes a flat plate held normal to the direction of jet. Estimate the force exerted and work done by the jet if Q equal to 76 liter per second. In the first case, the plate is stationary. If the plate is stationary, can we calculate m dot also? Okay, we'll calculate m dot later on. If the plate is stationary, is m dot is equals to rho into a into v. So fx equals to m dot. Final velocity, initial velocity is v. Final return velocity is 0 because the plate is stationary and is held normal. So this equals to rho times a times v, and this value is 0. So this is v square. Rho is 1000. Area is pi by 4 d square. Now in the second case, the plate is moving with a velocity equals to what? U equals to 1 meter per second in the same direction. So there is a definite change in m dot formula. It will be rho into a and the relative velocity v minus u. And therefore fx will be equals to m dot into v minus u, and the return velocity equals to what? 0. So this is rho times a times v minus u whole square. It is mentioned that the jet is moving towards the plate is moving in the same direction. So this time is u is going in the leftward direction. If it is going in the leftward direction, is it equals to 1 meter per second? Value is minus. So that is the only change. And therefore, this value will be equals to what? A times rho a v, v plus u. Minus minus will become plus. Now when I say plus, use positive sign. Or otherwise continue with the same answer that we have done initially. This minus and this minus will force it to plus. So you use the same formula and calculate fx. This time work is possible. This time work is possible is fx multiplied by u, and is it same as 3094? In the previous case, the work is also same because u equals to what? 1. So a jet of diameter has a velocity of 30 meter per second. It strikes a flat plate inclined at 45 degree to the axis of the jet. In the first case, the plate is no information given about the jet, so let's assume the jet is horizontal. And let's say this angle equals to what? Theta. This theta, is it the axis of jet? So it has this component and one component exactly parallel to the plate. This angle is 90 minus theta. So this one is v cos theta. This time we'll go for normal force again. So this one is normal force. It has two components. One will be like this, other will be like this. So this angle is same as theta. This is Fn, this is Fx, this is Fn cos of sine of theta. This is Fy Fn cos of theta. If you analyze like this, the problem is finished. So the m dot will be 132.5. So Fn equals to m dot into V cos 30. We have sine of what? 45. But it will be same sine and cos. Now we can calculate Fx. Fx is Fn into sine 45. I think Fy will also be same. Okay, what is the change if you go for the plate is moving with the velocity u equals to what? 15 meter per second. If the plate will move with a velocity of 15 meter per second, we have m dot equals to rho times a times v minus u. This time relative velocity component will work. 66 point. गलत हुआ, ये करेक्ट है? यू आएगा कि नहीं आएगा? यू आएगा कि नहीं आएगा? हाँ आएगा? ये तो चेक कर रहे हैं आप तो. यू आएगा कि नहीं आएगा? अगर नाउ सो fx will be equals to fn sine 45. $497 point. Is the work is possible or the power is possible? So yes, fx multiplied by what? Simply u. Okay, I will continue this problem. Can we calculate the input? Is it same as the watts also? It's same as watts. Can we calculate input power? Input power is in the form of kinetic energy, and is it half m dot v square? Correct? So this equals to what? This time input, only input. So is input is given by m dot rho a v multiplied by what? Again v square. Are we getting 59641 something? This one is output power. So what is the efficiency? Output divided by input. That is why we will never use the flat plate, because the conversion efficiency is very less, only 12.5%. Your objective is to increase the value of this efficiency. That is why we have a modification. That is why we are studying the curve symmetrical, then entry at center, then entry from one end, and we always try to modify the efficiency. So we have a diameter of jet is 75. So this angle equals to what? 30. This one is 30. Then the velocity of jet is 12. Initially the plate is stationary. So m dot will be equals to rho times a times v minus u. Equals to m dot x, m dot multiplied by what? Is v sin 30 or cos 30? So this one is either you can write v cos 60 or v sin 30. Now we'll prefer v sin 30 minus u. U is always 0 for the stationary. only for second case u equals to what, 6 meter per second. So what will be Fn in that case? Third part में बोलता है कि u की value, the value of u will be equals to what, -6, because jet is moving towards the plate. So this time Fn will be, use the same equation, 715.7. The sign convention will be like this. If u is in the same direction of v, take it positive. If in the opposite direction, take it negative. We have a square plate weighing 140 Newton, has an edge of 300 mm. The thickness of the plate is uniform and it is hanged so that it can swing freely above the upper horizontal edge. The horizontal jet of 20 mm diameter having 15 meter per second velocity impinges on the plate. The center line of the jet is 200 mm below the upper edge of the plate. Find what force must be applied at the lower edge of the plate in order to keep it vertical. When you read the problem, you come across hinge. Hinge means mechanics and hinge means three equations: sigma fx, sigma fy and moment. In addition to that, we have impulse momentum ID also. Is okay? So this one is the true shape and this one is edge view, and is this plate is hinge at the top, that is along the hinge, and is the jet is striking exactly at 200 mm. So this distance equals to what? 0.2 meter. And the velocity of the jet is 15 meter per second and the diameter of the jet is 0.02 meter. The balance you have to do by applying external force at the lower edge of the plate, and you are interested in this force F. So we have a impact force. Let's say this one is impact force equal to F1, that equal to m dot. The initial value is V, is the written value equals to 0. Correct? Answer is 70.7 Newton. Okay, show two more reaction before you go for moment. One reaction is this one, that is OY. One reaction is this one, that equals to OX. And now apply moment equation about point O. Three moment will be 0. One is OX, one is OY and one is W. Moment of F1 is anticlockwise and the distance is 0.2. The moment of F is clockwise and distance is 0.3. Just substitute this value and find the value of F, and confirm is 47.12. A jet of water having diameter of 50 mm strikes a stationary symmetrical curved plate with a velocity of 40 meter per second. Find the force exerted by the jet at the center of the plate along its axis. If the jet is deflected through an 120 degree at the outlet of the curved plate, the plate is fixed, so u is equals to 0. Approach velocity will be like this, and the approach velocity is 40 meter per second, and the diameter of this jet is 0.05, and this jet is deflected, so this is deflected like this. By how much angle? 120 degree. So is this angle from here to here, is it 120 degree? Correct. Is deflected by 120 degree. If it is deflected by 120 degree, then is the internal angle will be 60, and is this velocity is same as 40 meter per second. Therefore, is this component that we are only interested, is it v cos 60? So first of all, m dot rho times a times v minus u, but u itself is equals to what? 0. And fx will be equals to m dot. Now v is a positive value and minus of minus v cos 60. Substitute for everything. And we have final equation as rho a v square into 1 plus cos of 60. Rho is 1000, area is pi by 4 d square, and velocity is 40. Your approximate answer will be 7179 or approximately 7180 or 4711.2. A jet of water strikes a stationary curved plate tangentially from one of the end at an angle of 30 degrees. The jet of 75 mm diameter has a velocity of 30. The jet leaves at the other end at an angle of 20 degree to the horizontal. Determine the magnitude of the force exerted along x and y direction. So it enters at 30, leaves at 20 with the same velocity, assuming that there is no friction. So the x component of the inlet one, that is v1 x, is equals to 30 cos 30, and the x component at exit is v2 equals to 30 cos 20, whereas y component at inlet v1y is equal to 30 sin 30, and at exit it is v2 is 30 sin 20, and nothing is mentioned about the velocity of the blade, so we assume it's fixed, that is u equals to what? 0. Mass flow rate is given by rho times a times velocity. Remember, area and velocity must be equals to what? Perpendicular. So that is v component, not either v1x or neither v1y. Jet is going this way, so we want this area. So we are interested in v, and this section equals to what? Pi by 4 d square. Then you take the momentum balance along the x direction. So this is m dot. Direction of v1x is rightward, so we'll take it positive. Second term is minus. Direction of v2 is negative, that itself is minus. And for calculation of fy, direction of v1y is positive, that is 30 sine of 30, and the direction of v2y is also positive, so this is 30 sine of 20. Second answer. का ये भी एडवांटेज है, अगर आप सब रिजोल्यूशन कर लेते हो तो फिर आपको फॉर्मूला में फटाफट वैल्यू डाल सकते हैं आप लोग, and your solution will be very fast in that case.